is close to the deep sea and close to the fjords. It's a small island in the Herói Comuna, and this area is very known by the shipping activity. So here is our research station. We have labs, we have offices, we have a conference center, museum, cafeteria, and test facilities for ocean energy. And the scientific plan calls for work in the fields of oceanography, marine biology, marine pollution, deep sea and coast monitoring, and seabird monitoring. So, Runda Environmental Center is used to work in tight contact with the academy, business, and public sector. 40% of the center is from the municipality. So we need to help the regional development of more homestay comuna. So Runda Environmental Center want to create marine data from the industry and want to strengthen the regional business comuna and the scientific institutions in Norway. So Runda Environmental Center, it's part of the Blue Maritime Cluster. It's part of MAFOS, which is a very old shipping cluster in the area, and is also part of the legacy. We want to use the opportunity that Runda Environmental Center is part of these regional clusters to collaborate, cluster-to-cluster collaboration. But we have a long way to learn, and our consortium is just the beginning of this collaboration. But we already have good partners, and we will get to consolidate our cluster. So here is just a list of our partners in Norway. We have plenty shipping companies working together, the universities, consultant companies, and the clusters. And now our timeline. So our DeepSea pilot project started in 2015. Then in 2016, we organized a workshop at Sintef. Then I participate on a gravity survey on board the Deep Vision vessel in collaboration with Shell in 2016. In the beginning of this year, we organized a workshop at Biorio in Rio de Janeiro. Now we are participating today in the November conference, and we are also organizing a roundtable next Thursday to discuss the decommissioning process in Brazil and Norway. Next month, we are organizing a workshop in Runda, at the Runda Milho Center. And this workshop is, we are going to use the experts in autonomous vehicles for ocean monitoring. So we also plan to bring our Brazilian partners to take part of our discussions. And we hope to have our DeepSea environmental monitoring cluster ready next year. So everything started during this DeepSea pilot project. The DeepSea pilot project was a collaboration between Runda Environmental Center, Olympic Shipping, and Sintef. The main goals was to gather knowledge and data from DeepSea from the ROV sensors, uncover demands for new technology for ROVs, and strengthen the subsea fleet in central Norway. Everybody knows we have been through a high crisis in the oil and gas sector, so we need to create new business for this shipping activity, which is very strong in the central Norway. So we had the opportunity to participate in 3 missions on board the Olympic Arins, Olympic Zeus, and the Deep Vision vessel. We organized this workshop. And then during this workshop, it was just 20 participants, but high level of partners. And during the technology session, Sintef demonstrated some cameras that can see through the turbid water. And Kongsberg and Statkraft also present some new sensors that can detect different gases on the water. So this was the last year. I believe they are ready. The sensors are already in use. Things in technology go very fast. Also during this workshop, we get to know Daniel Jones. Daniel Jones is the principal researcher of Serpent Project. And we found out what we want to do, the way we want to work is what Serpent Project have been doing for 10 years. Serpent Project is from the Southampton University. And they already has a hub with centers in the United States, Australia, and in England. And they have been working in collaboration with the oil and gas industry, and they have been assessing the deep sea life and publish a lot of data. And now they just wrote an article about the 126 surveys in collaboration with the oil and gas industry. So we want to use their methodology and bring this experience to Brazil and Norway. And during this workshop, we managed to bring some participants from Petrobras, from Statoil, and some ICOM and other companies, and researchers from UFRJ and USP. And they presented their extensive experience using the ROV during the oil and gas. So this workshop showed that Brazil has a great experience with the deep sea, and the Norwegians wanted to know this experience and crossover expertise. Then during the summer of 2016, I went on board this Deep Vision vessel. It's a subsea fleet. We can say it was an opportunistic project in a way that we wanted to assess the deep sea life using the ROV during the normal ROV operations. So they didn't need to stop any operation or give us more time to use the ROV. And then we can consider that as a scientific visit. And this is the way we want to continue to work with the industry. Show to the industry that we can cooperate. And the oil and gas industry is playing a major role for the deep sea knowledge, because they assess the deep sea, they have the technology. So we want to use this data also for conservation. So this the equipments we use on board. It was during this the agreement with Shell was that we are going to participate during this gravity survey every second year and assess the deep sea life and check if the environmental is changing or not. So we will manage to develop a long-term study in this area. The area is Ormelange gas field. Ormelange gas field operates without platforms. There are 19 wells divided on these templates between 340 meters and 1,100 meters. These two 30-inch pipelines transport the gas to the Nihana Lands facility that export the gas to Great Britain. So Ormelange gas field produces approximately 20% of UK gas and is considered the third largest gas subsea field in the world. So for us, it's a great opportunity to be part of these gravity surveys and check how it is the deep sea life, how it is the local habitats, to help to understand the importance and the fragility of Norwegian deep sea scale and global scales. So we assess this ROV. I cannot show the picture of the gravity equipment, it's confidential. And the ROV have 8 cameras. And well, the gravity equipment is very big, heavy, and sensitive. And that limited our research because changed the buoyancy of the ROV, and then we could not use the ROV very close to the sea bottom. But anyway, we got a lot of good results. I will show you. We also assessed the CTDs on board. It's 2 CTDs, and we found out, for example, the temperature was positive from the surface up to 600 meters. We also registered alloclean and thermoclean between 200 and 400 meters of depth. So, with only 2 weeks on board and the limitation of the ROV, we managed to analyze 360 hours, register 176 marine animals. 76% of these animals were megabenthic fauna. That means animals bigger than 50 millimeters and living in a close relationship with the sea bottom. Here is some pictures of these animals. Well, as I said, we register a lot of animals, but many times, because of the gravity equipment, when the ROV comes close to the sea bottom, the sediment rise up and hide the camera visual field, and because of that, I decided to use a conservative criterion for classification of the species. We observe a lot of fishes using the CP stations to protect them from the current, the local current. These CP stations have been sitting down on the sea bottom since 2012, and they are used to as a foundation for this gravity equipment. 72% of the fishes was observed below 600 meters with temperature below 0 degrees. The most spotted animals is Umbellula incrinus. This sea pen have been registered in many other surveys in Norway. Looks like the populations are growing in this sediment with mud and sand. And this animal can grow up to 2 meters above the sea bottom. Is considered one of the biggest sessile deep sea animal in the world. I have a video here. It's possible to put a video? No? This is the creel. That was amazing because we managed to record the creel. And we only record the creel between 285 meters and 385 meters. So this can be a subject of study. Creel is very important in Norway and worldwide. And also, where we register the creel, we also register a rapid increase of salinity and a rapid decrease of temperature. We try to use the oceanographic data to check it out why the animals are there or not. So this data, this is just a pilot project, but we can see with a little bit access with the technology, we can really improve the deep sea knowledge. And that's something important for us. What happened? Okay. So through the project, we managed to check it out how it is the deep sea. We get to start up this network with the Brazilians, and after that we decide to continue this initiative, the network initiative. Then Rund Environmental Center, in collaboration with Innovation Norway, with the support of Research Council of Norway and FINEP, we organized the DeepSea International Consortium Workshop. That was a 2-day workshop. We have presentations, we have a round table, and group dynamic. So the general feedback from all 51 participants was that the presentations have a high quality and a multidisciplinary approach, and everyone wants to continue this networking. So we also want to use the momentum that the oil and gas industry is going deeper and deeper to study the deep sea life. And we believe this is the way to collaborate to get a better understanding of our environment. So we will try to use the arena model to build our cluster. The DeepSea International Consortium is in evolution to become a cluster. And we want to use this model because we want to create this arena for innovation, and where the partners can cross their expertise and create new ideas for business and create new ideas for research. So here are the partners. We have quite a lot from Brazil. The Brazilians have interest in this international cooperation, but the Brazilians also, the Norwegians also, they understand that the pre-salt, for example, the deep sea, the new deep sea fields are the new frontier for the oil and gas and subsea sectors. So we want to put these professionals together to create innovation, to create science. So we believe that our cluster will create this arena for innovation, and the main goals for the cluster are organize meetings to discuss trends and markets, packing service and products for the deep sea monitoring, and to collaborate with Brazil to get knowledge, capacity, quality, and cost advantages. We believe that what the scientists learn and share about the ocean can help the government and the commercial operators make informed choices. So here are our prospects. We want to build a new branch of the Serpent project. This new branch will also be, in a way, an innovation inside the Serpent hub, because we'll be the first Serpent bilateral cooperation. We want to use the companies as, for example, Statoil and Petrobras to get the images, to study these images and build a mega data base for the deep sea. So we will use, and one important thing is we will use the procedures, the standard procedures from Serpente project to get this data. Because in the workshop, one of the problems we found out about monitoring project is everyone is collecting data in one way. And then it's very difficult to compare this data, to create this mega database. And now we have this digitalization time. We want to use this also in our favor to create this mega database where the partners can access the data and can add this data in real time. And in that way, we will build a long-term study for biodiversity in Brazil and Norway. Another thing the Norway Serpente project is quite important is the DeepSea in Brazil and in Norway. They are hotspots, but they are not well known. So we need to fill this gap. And we believe we can do it, but we need collaboration to do it. So ProOceano, it's our partner in this building the mega database. They have quite good experience with IAGC. So we are working on this. And we are going to use CSA company to create our website so we can keep the network active and the stakeholders will have opportunity to publish their monitoring projects and the technological projects. So this is how we plan to work next year. This is our next event this week during the Norwegian Brazilian Science Week. So we invite multidisciplinary professionals to discuss the practical problems of the commissioning process in Brazil and Norway. We believe this collaboration can assure the integrity of the environment and assure the safety operations in Brazil and Norway. So we are also organizing this workshop. This is another project that Mirunda Milho Center is working in collaboration with Kongsberg, Avila, Fosnavåg Ocean Academy, and the Bergen University. And okay, and one more slide. And then in this project, we are in the end of the project. We are trying to build a competence in this regional area where we live in central Norway to work with the LVs. Everybody wants to work with LVs nowadays, so we want to also, we have experts in Mirunda Milho Center. We have a glider pilot from NACO project for 5 years working with gliders. We have PhD scientists working with gliders, so we are inviting the experts in Norway and the Brazilian partners of our consortium will come to Norway and get to know the Norwegian partners and update the network with the new hot topics we are discussing during this conference now. So we believe that working with industry, we can unlock the potential of the deep sea while protecting the environment and adapting for climate change. Thank you.
We are open for one question.
So thank you, Claudio, for your presentation, which was very clear for me that I'm an outsider from this area. But I wonder if you could speak to me, what do you expect to find in marine life in ultra-deep waters? And how is the advantage of this biodiversity study for those environment, for this environment?
Well,
you know, I'm an outsider.
Yes.
Maybe that's a silly question, you know.
No, first of all, the deep sea is very little known. So it's a new frontier. We don't really know so much, so we want to use the technology to know better. It's very expensive to go so deep. That's the main point. So we need the oil and gas industry to go so deep. The problem is, since we don't know what is there before the activity, it's very difficult to see what is the impact, how much impact the industry is causing. So we want to participate in this process and build up protocols to study and minimize the impact of the industry. That's the main goal. It's understand the fragility and try to protect, but of course we cannot say to the oil and gas company, don't work here. But how can you work without a big impact, for example?
Yeah, my question was because I've never seen anything in the deep sea at this level. So
yeah, but this is... Yeah, but I remember in the school also they said that the deep sea is a desert, but it's not. It's quite a rich biodiversity.
Okay, Claudia, thank you very much for your talk. Okay. I will pass the chairman for Professor Sigmund.
Yeah, the next presentation is control strategy for processing and flow assurance in subsea operation. And it will be presented by Agimiro Resende Sessier and Mauricio de Sousa, Federal University, Rio de Janeiro. So, please.
Thank you. Good afternoon. I am going to present our experience at our research group at UFRJ in the application of advanced process control techniques to offshore production of oil and gas and subsea operations. Professor Agimiro, that is present here in this, the co-chair, also belongs to this research group. So the outline of the presentation, first, we will discuss the challenges for offshore production, and then the approach we adopt for applying APC, Advanced Process Control Studies, that is based in the use of virtual plants. So I'm going to discuss this, and just for illustration, I am going to present an application in a pre-salt platform of model predictive controller using virtual plants. Then I will present some major subsea projects that we are working on, examples of these projects. So the ongoing subsea researches in our group, our collaboration with the BNSOC, and the final remarks. Well, the challenges for offshore production, we in Brazil, for example, as you see in this figure here, are now producing water, producing oil and gas in ultra deep water, far away from coast. And the oil, that is the gas and the oil, are being produced from the pre-salt layer. And the gas has a high content of CO2, which imposes some difficulties and special treatments. So there are stringent regulations that we are submitted to, and the process demands high costs. So other difficulties are for the allocation of multiple wells and the fact that the flow is multi-phase. Additionally, the implementation of new technologies for subsea processing have, with the objective of accelerating the production or improving recoveries, they have the fact that these unities are subsea, they are difficult to maintain, and at the same time they demand full automation. So if we also consider that the process itself is time varying, is nonlinear, is subject to severe disturbances, we have really a very big challenge. We have to, in this complex scenario, we have as targets to maximize the production of oil and gas at the same time that we keep the quality of the products and minimizing, in general, the costs. So we have many decisions to take. In the control, we have adopted a multi-layer control hierarchy so that these decisions that happen in different time scales, varying from the decision of a strategy of investment to control of a compressor, they are taken in different levels that go from top to down, from asset management and reservoir management, production optimization, and control and automation. So we are, in our research group, mostly devoted to these two levels here. Of course, that the levels are interwoven, but our main targets are the advanced process control and real-time optimization. So that those targets that I had presented before are dealt here. And in terms of the mathematical formulation, the optimization problem must also consider that the variables must operate between limits of operation due to safety reasons. So we have a constrained optimization problem. Well, as I said, how we have been working for the advanced process control. Mostly, we use virtual plants. We consider that virtual plants allow quick and easy testing of different control strategies. We use rigorous models, and as we are in contact to industry, we use data information from industry. We consider that these models allow education and training of engineers for these advanced tools. So we have been working with a simulator that was developed by a consortium of universities and industries in Brazil. So it's kind of like, I could say that it's ours. And its name is ENSO, which is the acronym for Environment for Modeling, Simulation, and Optimization. So ENSO, it's a chance to present ENSO to this audience. It has many key features. I'm not going to read all of them because it has many mathematical features that are very interesting. But I'd like to draw your attention that it is an open source library of models. And you can also interface ENSO with user code written in C or C++ and Fortran. So it gives a lot of flexibility. And then we can do a lot of things with ENSO. For example, steady state simulation, dynamic simulation, and optimization. Many tasks that are helpful for process control techniques. And we can also add new solvers, add external routines using plugins resource. So it offers large flexibility. Well, I am going to present at this beginning an application that was the application of a model predictive controller in a pre-sort platform. I'm going to present it very briefly because it was a top-side presentation development. We were concerned about the production of natural gas for exportation. And this gas had to be compressed, and at the same time, it had to be conditioned. So we had to study together with Petrobras. We developed the flow sheet in ENSO considering the process. So here is the flow sheet that was implemented in ENSO. We had to implement different models for this project and for others. We had to implement equipment models, like for the production well in riser, the three-phase separator, compression cycle models, and gas separation membrane models, and also for the regulatory control layer. In the case of high-content CO2, we used a plugin that is named VRTherm, which considered special thermodynamic models for that purpose, so that we are able to simulate that process. Here I show, I will be very brief, that we had many variables that were controlled, especially on the compressor. And so it's a multivariable controller, the one that we adopted. And then our objectives were to guarantee the safe production and the minimal energy consumption in the presence of measured disturbances in the feed and in the exportation also. We controlled the BHP, which is the power input for the compressors, and at the same time keeping variables of the compressors, temperature and pressure, between constraints. Here is how we, I don't know how, yeah, we implemented ENSO in the plant model in ENSO, and we were able to study the process control using MATLAB, for example. And so we had the results that I will show here very briefly. We compared the implementation with MPC and without MPC. And as you see here, the variables should be between constraints. And so MPC was always able to keep the variables between the constraints with less work of the compressor and less use of energy, as the MPC as a controller developed using a model of the process. So it does a better work. And this was for the main compressor. And for the export compressor, we had the same behavior, fast response, constraint satisfaction, less work and less energy. So this is an example of the use of virtual models and model predictive controller. And you can see that the results are that this controller resulted in better performance, and with that lower energy consumption, because we controlled the BHP of the compressors, and lower equipment wear. So the potential to economical gains. Now we are starting to work with subsea projects. So I am going to present some major subsea projects that the literature reports that exist around the world. And this author here, in a very recent publication, he stated that there are about 25 boosting systems around the world and around 7 separation systems. We separated them here as brownfields and greenfields. And you see there are some applications from Statoil in Norway, like Osgard, Gullfox, Tordis. And also in Brazil, here, Marlin, that is a separation system that I will present. And greenfields, like Shell in Perdido, and here in Brazil, and Total in Angola, as are some major existing. And I am sure that the optimization that I discussed previously, but using uncertainty can help the control of these processes. This is an illustration as an example of the Osgard subsea gas compression system. And as you see here, the compressor, if I go straight to the goal, the process, it is typically based on topside compression. And you have to worry with the occurrence of surge, which is a problem that is common. But so the goal is to operate with maximum productivity, minimizing energy consumption and avoiding surge, but in the presence of model uncertainties. So the compressor control must be carried on with the consideration that the model that we use in the model predictive controller, for example, is must consider uncertainties of the environment. If we go for an example of separation, for example, this one is Marlin from Petrobras. This is a reference that was published. So this one separates water and then polishes the water in order to reinject it in the reservoir. This project here has some characteristics like the dynamics is fast, and there are some challenges in terms of lack of instrumentation. You see, because you have to, as a goal, you have to operate reliably short to medium term with multiple wells, but without reliable or even without oil in water sensors that measure oil in water. So the well allocation problem should be carried on with optimization under uncertainty. So that's how we are working now. We are working with optimization under uncertainty. Another subgroup of our group is working with flow assurance. But the question of uncertainty is very important in this context. So I am talking a little more about the problem of uncertainty, because the subsea installations are difficult to access. They are very, if you have to, that is the need of intervention, it is very high cost. So the system should be self-controlling. And then mathematical models could be used to apply model predictive controller, to build state estimators, to enable the process optimization. However, the subsea is full of uncertainty. And where does this uncertainty come from? From the external disturbances, from the fact that the models that we use are simplified ones due to the computational reasons. The data that we have may be unreliable, so that we have to do advanced control, but in the presence of uncertainty. So we are working with optimization under uncertainty. And we are now working with this kind of model predictive controller that is a multi-stage non-linear, where we have multiple scenarios. So it's called scenario optimization. We have multiple scenarios in order to consider the uncertainties in parameters of the process. So each model predicts the evolution from a known state. You can have different scenarios, and you can compute the control actions considering all these possibilities. Now, one of our students is working with this problem that is widely known of the surge problem, that surge is an unwanted phenomenon that may happen in compressors. You can define a region of, using characteristic curves, define regions that should be avoided of surge. But as we have uncertainty, we use some safety margins in order to go away from that unsafe region. And so one of our students, that's named Ivo, he is now working in a collaborative project with a professor from NTNU, Professor Skogestad, and he is studying the anti-surge control, developing the model of the unit in ENSO, considering parameter uncertainties, and now he is going to implement the multi-scenario optimization and compare with nominal NEMPC implementation. Okay. This is another research line that professors from our group are working on regarding flow assurance. Flow assurance is responsible for identifying, quantifying, mitigating the risks of associated with offshore production, offshore pipelines in subsea. Because, for example, you can have formation of cleft rates, hydrates that happen in the presence of some formers, some gases under conditions of, special conditions of low temperature, high pressure, in the presence of water, then a crystalline structure may be formed, trapping the gases, and then the pipelines may present this formation here that plugs the pipeline with, looks like as if it was ice. And what we have been doing, we are developing models so that we can define the regions that are under the risk of formation of hydrate. And then we can, using models, for example, two-phase flow, predict the flow conditions of temperature and pressure that are inside the hydrate formation regions, and then apply control alternatives, like, for example, to control the topside choke valve to depressurize the system and go away from the region of formation of hydrate. So these are two examples of subsea work that we are developing now. This student, Geddes, is also expected to take part in the collaboration because we are taking part of this consortium that Professor Sigborn presented earlier, this B and SOC consortium. So one of our students is already there, and the other one is going maybe next year. So as a final remarks of my presentation, what I tried to present here is that we are trying to adapt and transport our experience that is mostly based in the development of virtual plants in ENSO and use of model predictive controller to applications of subsea. In the case of the presence of uncertainties, we are using scenario optimization. And in the case of flow assurance, we are developing also models so that we in further stage we can process the control itself. Okay. Our team at UFRJ, we have as I said before, we have Professor Admiro, we have Professor Capron, maybe he is not now here, and some other professors, and a large group of PhD students and Master of Sciences and undergraduate students. If you want to contact us, these are our main contact and Professor Admiro. Thank you. Obrigado.
Any question?
Thank you, Professor, for your great presentation. I'm Vinicius from Technip FMC, and also I'm a research and development engineer there, and also a PhD candidate at Copy UFRJ. Well, I work with structural reliability and also machine learning algorithm applications, and I still worked with statistical applications during my master's. And also inside reliability field, we handle with many algorithms based on statistics. When I see that you use uncertainties for your analysis, I could not see anything related to failure probability. Yes, we can play around Bayes rules, and we can play around with fault tree analysis, such similar that you showed before. And well, do you intend to get in the final to quantify the failure probability of your third event that's a failure mode? And then it's very useful to then calculate our risk in the final. That's it's failure probability times the cost of failure.
Yes. I consider that we can kind of work in two different levels. We can still pursue the use of this scenario optimization. You see, inserting the uncertainty in different ways of the way that we are doing now. For now, we are supposing that we have some sets of parameters that the system can vary, because then we use that for other tasks. For example, the prediction that I showed, these were predictions of what would happen, you see. Then we can use some statistical model in order to describe how these uncertainties will behave. And I think that will be kind of, because usually people do this without this consideration that I am using, of using multiple scenarios. They use the worst scenario in order to calculate the, so we are improving using different scenarios. But I also agree with you that we should describe the uncertainties not in the way that we are describing as if it was a uniform distribution, but using other different statistics. But I also agree with you that we should have other layers of condition monitoring, as Professor Bjorn presented here, that we could be monitoring the process. And maybe sometimes if you are near the possibility of having an abnormal situation, you can override this kind of control that I go and use other, you see, other strategies that would be necessary in terms of emergency. So I do agree that it is extremely necessary to have these fault detection techniques applied, but working together with our algorithms.
We are a little bit behind schedule, but I think we can have an...
From where can I download ENSO?
See? Sorry.
From where can I download ENSO?
Yes, it's because ENSO, you see, was developed. I am going to talk about this, but maybe Argimiro is one of the fathers of ENSO. Because... yes, it's kind of, the consortium is named ALSOC. ALSOC, yes. Yes, here. And then there you can download the latest. And you see here at UFRJ, at Petrobras, in some meetings, there are frequent courses on ENSO. Our university is working a lot with ENSO, but for example, people at São Paulo, Universidade de São Carlos, and now at NTNU, through our students, people are starting to use, and at Petrobras they use. So it's kind of spreading its use. It's an interesting alternative.
Okay, I think we have to continue. So thank you very much. Yeah, the next speaker is Cassio Cupil from Petrobras. He is his title is Brazilian Subsea R&D Challenge Operator Perspective. So please.
Good afternoon. My name is Cássio. I work at SEMPS, at Subsea Technology Group. I will try to give you one overview about our changes of the next years and maybe in the long future. The agenda, I will try to talk a little bit about the drivers, about these changes, and I would tend to discuss a little bit the main drivers that we are facing. This slide, it's an institutional slide, and it states that we overcome technological change, but it's more complicated than that. We have overcome, we are overcoming, and we will need to overcome a lot of changes. We have a long history in the subsea area, not just in subsea area, but drilling, reservoir engineers, and so on. We worked in deep water, started to produce marine field, about 1,000 meters. After that, roncador fields, and now we are producing the pre-salt. All these changes were related with environmental conditions, changing environmental conditions. We need to develop new technologies to deal with these environmental conditions. Maybe in the future, we'll face another kind of change. We'll face the need to optimization, economical optimization. Here, up to now, we have worked, our industry in general, with enabling technologies. But now, in the future, probably work more in optimization technologies. But it's not a straightforward, that small optimization or small changes. We will need step change technologies to deal with the future needs. In the pre-salt, we face deep water, some sea conditions more challenging that we have faced in the past. The conditions of our fluids with CO2, high content of CO2 and H2S. We have been able to overcome these challenges. We are producing nowadays a large amount of oil. About 50% of this production is being carried out in pre-salt. And this production will increase. These figures, excuse me, they have some meshes. We have some meshes here. It seems that we will have an increase of around 40%, 50% in production. But there is some other issues that this is Petrobras production. In fact, part of this of increasing oil production as Petrobras as operator will belong to other operators, our partners in the production of pre-salt, which means we will produce more than 3,000 and 4,000 barrels per day. And the other important thing is that we will have the natural decline of the mature fields, which means we will need to install a very large infrastructure to achieve these productions. Which means we'll have some pessimism in our industry. It seems that we don't have many projects in the near future or in long-term future. But the message of these curves is different. We'll need to have many equipments, many subsea equipments, many subsea servers in order to achieve this production. How I said, we'll have a natural decline in the production. In the world, we have around 12% per year. Here in Brazil, we have around 9%, and in Norway, we have better figures than that. And we need to deal with mature fields. Petrobras and Brazil is pre-salt, plus mature fields. And in terms of mature fields, we have a large infrastructure installed, some fields producing for more than 20 years, around 30 years in some cases, and a very large subsea infrastructure. We will have new infrastructure. We will need more than the double, to double what you have, but we need to deal with this old infrastructure. Another point, another important drive is the oil price. Most of the foreseen is that you have a stable oil price, which means we will need to deal with these pre-salt fields and with these mature fields with this pre-salt, with this oil price. Petrobras, in order to deal with these situations, in the past, we have the PROCAP, a technological program to develop technologies to produce in deep water. We have now the PROSAL that develop technologies to produce the pre-salt area. And now we are creating and start the cost reduction program, which would be our main challenge in the near future. Then the main message is that our technology development need to deal with many different life cycle business. We need to deal with appraisal, greenfields, and brownfields. And it needs to support all this life cycle of a field. And a main message about the drives, the cost reductions, the main drive, investments in various fields, most in pre-salt, but we have important investments in mature fields. And another issue, important issue, our industry have fair pressure from the society to deal with environment, ensure integrity, and increase safety. I will talk a little bit about these issues. The first point is cost reduction. One important message about cost reduction is that we will not get very good result just working with the subsea area. We need to integrate the areas. Probably in this integration, we'll get better results. We need to integrate the topsides, control, subsea, drilling, reservoir, and so on. One important SF system, it's technologies that you are developing, we are studying to some fields that have high CO2 content. Special thermodynamic characteristics of higher CO2 contents is that you have some thermodynamic properties with high pressure that leads to the possibility to have separation, liquid-liquid separation with one phase with high content of CO2. Then it's possible to reinject this CO2, avoiding the need to high costly topside system, which means we are dealing with increased recovery with this CO2 reinjection, simplification in topsides, and environmental benefits, avoid the production of CO2. Other optimization in terms of subsea is simplification in layout. I'm showing here some optimizations that have been carried out in Press-Salt. We have developed some design tools that improve our mooring and our riser design. With this tool, it was possible to save a lot in terms of layout, in terms of language of flow lines, and so on. But we can have important improvements developing new tools and developing flow lines with new materials, and eventually develop new equipments like pig launcher, like spreading the use of multi-phase flow meter, where Norway have carried out very important works in academy and industry. Maybe this partnership could help us to use in a better way multi-phase flow meter, and this could lead to better layout and better subsea arrangements. Other important issue is simplification in equipments. Here's one example in flow lines and risers. We have improved our design tools used in academy, and we have been able to use less buoys in these risers. But eventually you could have step change improvements. Using of new material, the academy and the industry could help us to develop new simplifications. Excuse me. Other issue is simplifications in Christmas tree. We have carried out a cost reduction program to try to simplify Christmas tree. We have worked with suppliers, but we will see possibilities to simplify more. And this additional simplification would involve decision tools, because sometimes you have trade-off between simplification in terms of CapEx, cost of OpEx, and it's very important to have knowledge and tools to carry out this simplification. It's not just good equipment. It's necessary to have decision tools in order to simplify so important equipments. Other area of optimization is installation. We are now using what we call CESV. Is a vessel that have been conceived here in Brazil and have been manufactured in Norway. It's operated by a Norwegian company, and it allows the installation of some subsea equipments like flow base, Christmas tree, with a lower cost than the traditional way using rigs. Other example is the pendulum installation methods that have been involved in the academy to carry out some tests and simulations about this installation method. Here it's another partnership with the academy where we have worked with Universidade Federal de Pernambuco. They have developed a tool that's able to evaluate the shape of the flow line during a vertical connection of this flow line with a subsea equipment. And with this information, it's possible to accelerate the installation process and mainly have more safety in the installation process. It's one important example. Other issue is integrity. We have integrity in mature fields. That's a very complicated issue because we have many different equipments with different situations. In some cases, we want to extend the life of these equipments. In other cases, we need to just to guarantee the integrity of these equipments, which means we need the support, many technologies to support the integrity of mature assets. In new assets, we need to think ahead the integrity issue. We are working in a more complex environment, but and eventually we will work with more complex equipment like subsea process and so on. And to work with this complicated issue, Petrobras has worked with a university in order to prioritize some projects. These projects are related with risk-based integrity management. It's management tools, the development of real-time monitoring system, and autonomous inspection systems. In terms of technologies to mature fields, how I said, it's an important issue to Petrobras. We need to remember that pre-salt will be mature in the field, and it's an important knowledge. And Norway, they have a good knowledge in this area. We have just signed one agreement with Statoil to change information in this area. In terms of subsea technology, the subsea technology could help to increase the oil recovery using subsea process. Not just using subsea process, but subsea process is an important tool. Petrobras and other companies, how mentioned here, have worked with subsea processing, but we have a big challenge with this oil price. Then we need to optimize, in terms of costs, this system. And this optimization is not just simplification, try to cut small costs. Maybe you need new technologies to have very high cost reductions. Here, again, we have worked in partnership with Norwegian companies. All the systems that have installed are using Norwegian subsea pumps. This system we have worked with a Statoil patent, which means we have had partnerships to develop this system, and maybe you need more partnership to carry out this optimization and simplification. Other issue related with mature fields decommission. I think that we'll have a specific meeting to discuss this issue. It's a very complicated issue when you deal with subsea equipments. We have a lot of challenges in this issue. And finally, we have a relationship between the subsea technology and the environment. We have had a very nice presentation about the DeepSea program. And I intend here just to present what we consider nowadays our main challenges in this area. The first is biofouling. Biofouling by bioinvasors, no indigenous species, in spite of some of these species are very beautiful, they are invasors, and they compete with natural corals or natural species, which means we need to develop technologies to deal with this biofouling. This is a very important issue, and other important issue is mapping sensitive areas. We have in some areas like Marine Field and other fields, some deep water corals and rhodoliths, and we need to deal with these species and develop tools to inspection mainly in some sensitive areas. We have some important sensitive areas where we have a special subsea inspection tools to exploit these areas. Then a brief summary of what I have said. The main message is a message of certain optimism. We'll have a large investment in the subsea area, maybe less than we foresee in the past, but for sure will be significant. We will need to deal with low capex and low opex. Integrity, reliability, safety, environment are very important technologies. We'll need to produce and to deal mature fields. We'll need to work together with other areas to increase recover. We will need to deal with decommission and so on. And we'll have a large range of demands. It's the subsea area. It's not. It's a very complicated area because we'll deal with a lot of expertise, and we need to integrate these expertises in operators, suppliers, and academia. That's a very big challenge. We know that Norway has some ability to deal with this complicated scenario, and maybe could be opportunity to work with Norway because we could have some improvements in the way that we work here in Brazil with so complicated scenario. Okay, thank you.
We have time for one question. Short one. No question? Okay. Quite clear? Yeah.
Hello. Hi, I'm Anderson from Repsol Sinopec, Brazil. I think I know you from a couple meetings.
Yeah.
Yes.
Yes.
So I also work in subsea engineering. I'm in the R&D department at Repsol. So I was just wondering, because you presented many different equipment for subsea processing, that's past experiences from Petrobras, and one of the understandings that we there have not been a part of the development of those equipment is that a lot of those were very tailor-made, and for that reason were very expensive,
Yeah, exactly.
and in turn would probably not work nowadays. So what's Petrobras' mindset currently regarding the standardization of those sorts of equipment, and how does that fit into the cost reduction strategy? Because I feel like that's a very key issue in bringing those further.
Yeah, it's a very good question. It's a very important issue. We are right. We have carried out tailor-made projects. It's amazing. In the system, we have three subsea pumps with three integrations, designs, different three integration designs, which means standardization is an important way to cut costs. the NV is carrying out one joint industry project in Norway, and Petrobras participating of this project in order to try to standardize subsea multi-phase pumps. But we need to standardize other issues in subsea processing, not just the pumping system, but other components maybe could help us to cut costs. But again, in some cases will be necessary to have new technologies to have a very high very high good costs. Okay.
Okay. Thank you.
Thank you.
Then we are ready for the last speaker, and this is Professor Muoka. He will talk about subsea operation from a floating rig. So, please.
Thank you very much. Firstly, I would like to thank for the organization for this opportunity for today, this presentation. Thank you for the audience for this last presentation. I heard that the best part of the last presentation of the day is what will come after the last presentation. So, thank you very much. What I would like to do is to show, I divide my presentation in two parts. The first 6 to 7 slides is just to give an idea what we did, what we do in terms of the research from the past in our group, in our research group on offshore petroleum system at University of Campinas. We focused on these offshore petroleum systems. And the last slides, just to show one application more close to engineering, what we developed as a project using result from the research that we developed in the group. I think we need this one. Okay. So, this slide show in the left-hand side in the upper part one of the topic, influence of the riser internal flow. So we basically develop numerical theoretical models to represent forces in pipes. We are in our group we are concentrated on underwater systems. Pipeline system, riser system, connected at the surface vessels, and what will happen in the connection at the bottom. So we are mainly focused on underwater systems. And one of the topics that we developed is how the internal flow in the pipe will interact with the pipeline, and how kind of force comes from this flow. Remembering that the flow inside the pipe, when you produce the oil, petroleum, and gas, is a multi-phase flow. So this kind of flow induces a lot of forces against the pipe. Another issue is the current and the wave forces on the system. So the dynamic behavior of the pipeline and riser systems due to this sea environment. And finally, what happens when the pipeline touches the bottom of the sea. So the movement of this pipe will interact with the soil, and of course the soil will make the impact on the resistance of the pipe. So we are mainly looking for those kind of effects, and developing numerical models, mathematical models, and doing experiment in the laboratory in order to validate those models. in different configuration. We have several operational conditions and situations that those systems are operated for offshore drilling and offshore production. So we are looking for those different conditions. The following 3 slides is just a list of a top project that we developed, research project that we developed in the past. I will just go through quickly. This is the subsea equipment installation and operation. So vessel interacting with the riser and the equipment at the bottom part of the system. In the re-entry operation, so where you have a very heavy BOP at the termination of the riser, and how to approach safely and how to approach quickly to the wellhead, and how to control this approach. When you do the drilling of the wellbore, you have all the dynamic of the system, and you have also the drill column inside of the riser pipe. So during this behavior, how the riser column riser will interact with the wellhead. This is another study we did from the past. What will happen inside the wellbore? So one another topic we are focusing in the group is the integrated barrier in terms of the safety operation of the wellbore. So what could be considered as a barrier, and how count these, how many barriers you are needed to have a safety of the well operation. So this is another topic of our research group. Using those model, we applied that for, I would like to show only one example of the project we developed, is the moving the drill ship with a suspended BOP. In order to accelerate the operation for drilling wells, instead of you recover all the BOP system to the surface, the idea is to recover only the first 3 or 4 joints of the riser column. So you have a long riser with BOP suspended, and the idea is to move for the new site in this way. So suspending the BOP. So during the movement, you will of course face to the sea environment. So what will be the operational limit for this kind of drill ship movement? So this is the issue in this project, the main issue in this project. So the idea is to quick the deep water drilling operations, not recovering all the drill column, but just the few the first few joints. The idea to solve this using all those models that we developed through the research, having the riser configuration, the drill ship motion, and sea condition, we have condition to make the time domain simulations, and through the time domain simulation, we have the riser and the system response extreme values, and with those answers, we are proposing to draw operational maps. So through the operational maps, you can find the safety zone for the operation of this kind of drill ship movement in different sea conditions. This is just a sketch what is happening. We have the drill ship, the drill platform at the top, the riser and the BOP at the bottom. You have the current wave, and you have the drill vessel moving against the wave in very deep water. We model the top connection with the platform. There is a gimbal, a spider, that so we could model this device in our model. Through equation of behavior of the riser and the platform system behavior, and considering the hydrodynamic forces through the current and sea waves, we are able to estimate, to predict the behavior of the riser vibrations and also BOP motions at the bottom. And how much is the angle between the BOP and the riser, what is very important in this operation. We consider different sea conditions through different, from this model. We used this kind of wave model, PM wave spectra. And we calculated stresses in different parts of the system. If the stresses estimated, of course, you can go, for example, to evaluate the fatigue problem in the system. Simulated in different conditions just to varying the significant wave height from different values, the mean period for the wave spectrum, and we also considered a varying profile for the current in the place, and different advancement direction for the platform. We considered the motion, RIO, the motion of the platform, heave motion, sway motions, surge motions. This is just the data of this case. Another data that we took into account. And we simulated the result, and this is just an example of the displacement along the depths. So you have the length along the depths for the riser, and at the end you have the BOP position. At the upper part you have the platform. So you have you can have the displacement, rotation, vertical displacement, axial forces, bending moment, and of course the tensions, the stresses. In this case, we evaluate through the von Mises stresses, comparing with the maximum stresses that the materials, the steel, allow in this case. Then, with those results, we are able to build this kind of graph. You have the period, wave period in the horizontal axis. You have the wave height in the vertical axis. And you have the contour for different stresses that we found along the system, especially in the riser part. And we have the limit, in this case, 300 in red. So above those, in that region, above those line, you have, let's say, the dangerous operational sea conditions. In this case, for the vessel forward speed of 0.4 knot, and going to the direction for the north, from the north, 180 degrees. So in the opposite direction from the north, for the south. So when you advance to the south with 0.4 knots, what happens with the stresses for different wave and wave periods? So with this kind of map, the operator can guide how much is the limit that he can operate this moving operation. Another way to show the same result, directions in the round way. You have the wave height in the vertical, and you have the contour for the forward speed. So with this kind of map, the operator can guide how much is the limit that he can do this operation. The big question was how much is the forward speed that I can go. So this is the main question from the operator of the drill vessel. Just some conclusion from this part of the work. I think the most important is this operational map that can help decision to speed up or slow down vessel speed safely, reducing downtime of floating drill rig. I did a mistake in this acknowledgement. I forgot the Human Resource Program of ANP, National Petroleum Agency. So thanks for our support along the years. And thank you very much for kind audience. Thank you. I'd like just to add that we are now partner in the IMPART project, and we are talking with Professor Sandsberg to trying to define the details for the collaboration.
I would like to make a question about former research you mentioned. I mean, this research related to inner, outer, and structure interaction in rhizos.
Yes.
What type of interaction did you consider? Is it one way, two ways, three ways? I mean,
we are considering the quantitative, the mass force, the inertial force when the gas and the liquid moves along the pipe. So we are actually this part of the project was developed with my colleague that working in more internal pipeline internal flow, and what we consider here is the inertial force along the pipe when gas and the liquid moves along the lens. So in all directions, of course, in 3D directions.
If I understand this correctly, you need a quite accurate positioning system. What kind of positioning systems are you using when you calculate this position for all the, or is it just simulated here?
You mean simulation of the re-entry problem? Which kind of simulation you mean?
I mean the data collection when you put this into operation. You need a positioning system of the vessels and everything that is moving around.
Positioning system of the vessel, you mean?
Positioning system.
Yeah, usually the GPS dynamic positioning system is used as a reference for this positioning. Yeah, but sometimes you use a special sensor in the system. For example, if you need to know where you have where your BOP is exactly going, sometimes you need another kind of sensor. Or if you need the information about the stresses, sometimes you try to catch this through another kind of sensor. So it depends on, but the position usually by dynamic positioning system.
Maybe I think you think about the lesson,
Okay. There is accelerometer usually installed in the vessel. And
what are the accuracy you need in order to do this calculation? How detailed, how accurate do you have the calculations of the positions and everything that has to do with the movement of the vessel?
when you try to keep the position for the platform to do some kind of operation, you don't worry about the movement you have according to the wave. Just how you are worried about how much the wind will take the system away, or the wave force that push your system away. Not that the cycle motion of the vessel. It's not the system, the dynamic position system does not work for this kind of movement, for this kind of motion, just to keep in position for the constant kind of forces.
Okay, thank you. Can you say what is the worst movement? Is it the heave?
Depend on the operation you are doing in the well or in the seaboard.
I mean, when you move the rig.
When you move from one position for another with the suspended BOP.
Yes.
In terms of the stresses, the lateral motion is more critical, like surge and sway motions of the vessel. But the heave motion is another, let's say, very important motion that we need to take care, because we are there are some possibility to have compression in the system. So this should be more accurately studied. We need more investigation this way in the heave motion.
Okay, thank you. Yep.
Thank you, Professor. Vinicius again from Technip FMC. You showed some pictures about your studies on risers and soil interaction.
Oh, yeah.
I'd like to know more about your studies on that, in your projects about that.
We have a lot of work done in the literature, and of course we can use those published work to have reference. What we did in our case, we did some basic studies. We, of course, developed some numerical models, some own program, and also we use some programs, commercial ones, and developed numerical models. And we also did some basic experiment in the laboratory, measuring how the pipe behaves when you have different kind of soft soil modeled. And we observed the behavior, and we compared with the numerical result in order to calibrate our results.
Basing tests? You've done some basing tests?
Basic.
Basing.
Basing, yeah. We
like
found,
TPN tank.
Yes, in air and also immersed in water. Right. We have a small tank, and we can do some basic experiment in this small tank. And we have some kind of forced motion device, so we can make cyclic motion into the pipe. Yeah.
Maybe we can discuss later.
Yeah.
A little bit more about that.
Okay, thank you. I think we are on the at the end. Thank you all for coming. There will be a bus outside leaving in 3 or 4 minutes. So if you want to go to this cocktail and dinner at Fogo, there is the bus is heading. So thank you.